Today, I will be showing you some versatile USD workflows using Maya and Houdini. I will be using Kitbash to generate a big environment scene using Houdini's native scatter tools. I'll be also using Vellum, I will be using FX volumes and all sorts of little other tricks. I'll be creating some HDAs as well, so it will be a quite action-packed tutorial class today. So make sure to support me and follow me on Patreon. Alright, as you can see, we are in Maya and I open up the Kitbash scene I got, and it is an Arnold scene. So every geometry here has a shader assigned already. You can see a couple of shaders connected. They are pointing to some texture on disk. But before we want to convert this to USD, what I always like to do, I want to clean up my scene so I don't have any weird naming conventions or my file paths are corrupt or something like that. I want to first of all rename everything that has this prefix for the Kitbash scene in it. And I use ChatGPT to help me quickly create me a for loop to clean things up. And I just need to run it, and you can see all of the prefix and suffixes are gone from all the nodes you can see in this scene. So texture nodes, shader nodes, everything. The other step, what I need to change is my texture paths are pointing somewhere. They also have that name, which I also want to remove. So I have a different path here, which essentially does the same. It just hard codes the path it finds from disk into this section here. So now this is filled in properly as well. And that's pretty much all I do. Now I'll just do a quick test. So I'm opening or creating just a simple sky dome, and I also save my scene. And once that is done, we can hit render and see if everything is there. All right, and as you can see, all the textures are connected and we get shaded assets from the smallest to the biggest one is all working quite nicely. So in the Arnold menu, if you have that installed and you are in a pretty recent version, you can go scene export and export everything to USD. A little bit of a caveat is you want to disable a couple of things because by default, it will literally export everything. So I won't overwrite this because this is the one I was setting things up, but I just create a new one called training. And just make sure you disable a couple of things. You don't need color managers, you don't need operators, no filters, no drivers. Essentially, you need shapes and shaders, and that's pretty much it. And then full paths export, and you export this, and then you get a USD file. All right, so all I did now in Houdini, I switched my view to Solaris. I have the stage on the right and my scene view on the left. And all I created was a sublayer like that. And I'm just pointing that to the USD file we just exported. So it's the outpost, the USD file. And it's the same thing as we had in Maya. It's the same layouts. Everything is the same. It's just essentially converted to a USD scene. Also, all our materials live now here as well, converted for USD. It's Arnold materials, so that is all. In order to create an environment, I want to be able to pick and place certain buildings, certain foliages, flags, antennas, and I want to be able to place them manually. In Maya, potentially, you would just select them and transform them where you need them to go. It's a pretty cumbersome way, or there's obviously you can use Mesh or other things in Maya to do it, but I like the Houdini way. It's very procedural and you do it obviously through USD, which you right now cannot do in Maya. My script here is split in two sections. The top one is the ingest, where I'm actually doing lots of work to separate each element and make sure I've got proxies and shaders and textures. And then the second part is actually where we do the environment stuff. And I'll walk through everything in detail so you will not be missing out on anything. We are starting out with creating a selection. The collection name is a subset, and it's a similar like a Maya set. And I'm just putting everything what is a geometry subset in here. So all subsets essentially live under this collection name, and they are being stored under collections. Let's see if we find that in this long list of things. I've got collections here on the left, and in the scene graph details view, you can always see what is included and excluded in this. And right now, this one includes all of my subsets. And a subset is essentially a geometry selection or face selection. You can see all these subsets and they have different material assignments. That's how this specific Kitbash scene is set up. I'm just storing an attribute on the subsets named material bind. This is used later on to actually assign shaders back onto each individual subset. And then another collection of every top group of every asset is essentially in here. All right, and now you can see now out top in is a null. It's essentially a pointer saying, okay, this is now a next step in our graph. You can see at the bottom of the first section there's like this top net. And the top net is actually pretty cool. You can see I'm pointing it to a lop path, can generate that file. And you can see I'm looping over every asset in my collection that I just created. So everything which has GOP in the name is a part of that asset collection, right? So I'm looping over everything. And you can see now if I hover over this prim name is antenna A, then we've got building MD or whatever. So this is essentially my loop over everything I want to go. And then I'm creating an attribute because this prim path sometimes changes and I just want to store this attribute into a new attribute I'm creating. So if you look at this guy here, you can see now I've got a current prim path, which is the same as a prim name or the prim path here. It's just a copy, which I reuse in the nodes above. And this ROP USD will actually write the prim name to disk in a separate single USD file of that asset name. And this is where I'm generating a USD file per asset. Now, if we go back to the top here, you can see that the variables I created in the top net will be used in here. For instance, in this prune here, I'm literally removing everything except the current prim path. You can see it's set to deactivate the other things and prune unselected. It's essentially an isolate mode. And this red node here, it's a Python script, which took me quite a while to create and think about how I can do this. And by default, the Arnold shaders are not represented in the OpenGL viewer. And in order for this to work, you would need to create a material network, create a USD preview surface, and connect everything. I can show you an example in a little bit. The problem though is with this ingested scene, I do not have access to the original material networks. So all I'm stuck with is the USD materials in here. So I had to find a clever way using Python to actually generate these USD preview materials on the fly and create USD textures and roughness maps, hook them all up into a USD preview surface and connect them to this material node. And you can see once I'm visualizing this red node, you can see at the bottom here in the details that there is now a output surface connection with a USD preview material. And this took me a little bit of trial and error. I was using, again, ChatGPT to help me out a little bit quicker because otherwise I had to go through the API and find the correct calls here. But with ChatGPT, it's quite easy to find APIs. And now this is literally displaying my base color texture in the viewport, which is super handy. Then I'm just doing some cleanup because not every geometry here has the same shader assigned because I've got all the shaders always for every asset. And here's what I was saying before. I'm looking at the current geometry prim path and I'm looping over the subsets and I'm extracting the material names which are on this asset. And then I'm looping over every material in this lower section here, and I'm deleting the ones or deactivating the ones which are not on this asset. And then they just get tagged off. And then I'm just left over with whatever is needed. And that was the material assignment stage. Now we always want to create proxies to work very efficiently. And I was creating a sub-modify network, which is essentially a sub-context, which allows me to do some sub-operations. And all I'm doing here, I'm putting in or I'm bringing in the geometry of that asset. I'm deleting all the unneeded nodes, deleting all the groups, and then I'm scattering a lot of points on this geometry. And then I'm creating VDB from those points, reshaping them, converting them back, and then poly-reducing them, that I just have this really ugly looking proxy, which is exactly what I'm after. Next up is I'm just cleaning up the primitives, and primitives are everything which are in this stage essentially. And I'm just defining what is a proxy. For instance, once I bring that in, I've got this proxy option here, and I'm just saying, okay, this primitive path its purpose is proxy. That just means that whenever I change my preview to final render, that they will be toggling between proxy and render. And there's a couple of things, just changing the scope types and setting the purpose to render stuff. All of that. And then at the end here, I'm specifying my save path for this current USD file. You can see if I expand this, this goes to antenna A, group A USD file. If I now change to a different task, you can see that this process be recooked, like it's restructuring, it's redoing everything. And now a different asset is here. And you can see that this process runs over every prim path. And now this maybe works better. Yeah, now I can easily switch between proxy and final, and this is essentially what is being done. And this is the first step of my ingest. So I did that, obviously took some time to set everything up. And again, if you want this whole setup, which is quite complex, especially a couple of the Python nodes in here, it's all accessible through my Patreon if you want to support me over there. You just will not get the individual assets itself because they were purchased, and you would need to do your own purchase or create your own materials or geometries. Let's just quickly jump into Nuke so I can show you what we will be creating, right? I guess you know because of the thumbnail anyways. This is the final result. You can see there are lots of things going on. We've got obviously the buildings, got props which are not in the kit bash scene. It's Megascan props. Got telephone poles. We've got wires everywhere. We've got volume, smoke, all of that. So I'll be showing you step by step what happened. I have a ground plane. It's just very basic, a plane with a mountain, I believe. And then I have a camera view, which is just very low to the ground. And buildings tall is essentially already my building placement. You can see these are my simple buildings and more buildings being added on top of the buildings like that. And it's pretty nice, pretty easy to do. And I show you quickly using the lob layout node. If I hook that in here, and then in my layout asset gallery, what I can do, I can say, okay, I want to have these buildings as my instance objects, essentially. I want to do a couple of things before. I don't want a scale. I just want to keep this very simple. Scale from original size, align to normal, that's fine. Asset can be cycled. I want to lock this scale and I don't want to save rotations. Go to the manipulator and you can see now we already see the first asset popping through. I just want to go over input instead of all. This just means that collision objects are a little bit more simple. And now it's just about creating these buildings. So I can click and then I can scroll to pick a different one. Click and you see this is essentially how I created a basic layout. You can also use the line, which helps as well for placement. And you can essentially click and drag and it just populates the line with buildings. And that's also what I did as well. Like that. And then you can pick smaller items. You can switch then to final render to actually get some textured views. You can remove your objects from here. And maybe if you want to create smaller props now, you can drag these guys in, activate them, and maybe do a second row of smaller pieces. I don't know. I'm just doing it very quick now, right? I think in most cases using the place node where you can click and rotate things. I disabled the scale, but we can just enable this back. And see now we've got a huge tower there. But yeah, this is essentially how I created the layout. And then I was going down low with the camera and then creating the camera from view. But yeah, this process takes some time to populate the scene. But yeah, you can see this is how it is. Technically, you just see maybe 4 buildings, but the scene itself is actually a lot bigger. There's a lot more going on. But yeah, I have a big FOV. So I think 105 is my lens. Yeah, so it's really long lens. But yeah, now let's talk about the rest of the things I did. So this is a volume instancer here, and this is instancing volumes, which I saved to disk. And you can see it's called Smoke Chimney. And we also have another Smoke Chimney B, I believe. And they were created in the object context under chimneys. It's essentially an AXIOM simulation. with a very simple source shape, AXIOM solver. And this is one of those smoke plumes. And they look like this, right? And I got 2 of these, and I just rotate them and scale them. These are showing all the fields, but that's one of those plumes. If I go back to the LUPS context, you can see I have both in here. And you might wonder now, how did I scatter them? In the instancer node, I brought in all the buildings, and I pruned all the antennas, and then I found a way to just, I deleted a couple of packed points, so I just have a little bit less antennas. And then using group expressions, I have picked the top points of each antenna and packed that. So in the end, I was just left with the top points. And then I applied a random p-scale, so I have bigger and smaller smoke plumes. And then they are just being instanced on these antennas, essentially. Very simple way to scatter smoke. It might not be placed perfectly, but I think it suits the shot or whatever. It just seems to work quite well. And then the next one is dead shrubs instancing. So these dead shrubs are coming from my asset library from Megascans. And I have, I believe, under, where is it? 3D plants, dead shrubs. So using OD asset library, you can find this third-party plugin in the description if you feel like it. And it just lists my Megascan assets on disk, and I can drag them in, and it will create me this little sub context here. And within, it's pulling in the FBX data. And my shrubs, it's loading in the LOD, it's creating the Arnold material. And this is what I was saying before. You have to create this USD network in order for this to actually preview an OpenGL. And all it's doing, it's creating a preview USD surface. And then I have color, roughness, and opacity. I've got a control, which I just need to change the name to the current shader and then hook both up to this output thing. And then once that is connected, I need to make sure that the output is assigned to my geo, output being this node here. And then on top level, now you can see if I go smooth shaded, this is now my OpenGL view of a single shrub. And if we jump back into the point instancer, I'll just show you how I did scatter them. I obviously brought in the geometry. I just kept the ground, subdivided it a little bit more, and created some density noise. And I also brought in all the buildings, rayed them flat onto the ground, and then created a density attribute on the flat buildings. And the reason for that is I did an attribute transfer, and whatever is a building, I don't want to grow shrubs around the underneath the building. So that's my method of doing that. And then a bit of custom curves to clean up some pathways. Did some blurring of the attributes, nothing crazy. Brought in the shot camera to remove everything which is outside the camera. So I do not scatter points which are out behind essentially the viewer, which we don't need. And then I'm using scatter align to create all these points. I have my orientation on them. So I have random tilts essentially and random y-axis rotations. Random p-scale adjustments as well. And that's my points. And now if we look at the instancer, but now everything is back to scale. And if I look through my shot camera, you can now see we've got these little shrubs here in the foreground. And it's more apparent if I bring back the wireframe. Then we've got small little rocks and very similar setup. I won't go into this. So it's essentially a copy of the previous one, just the different assets coming in. And then same way with the grass, I just did a different seed value. And now we've got also pebbles being instanced on the ground and everywhere around. You can see they're very subtle, but in your face enough to see them through. Oh yeah, I did a different method to bring in my wires, and they were created in here. You can see it's a little bit more complicated, but they all start out with the same way. I'm pulling in the buildings, and then on the buildings, I am finding the top points again. And you can see now on the antennas, I've got my top points here. I did a connected JSON points, pieces, 2 points, not to create me these lines. And then I'm just resampling them so they're all nice and smooth. pinning the points which are where the antennas are, applying a vellum cloth sim on it. You can see if I go to first frame, if I hit play, bloop, that's all it's doing. So now they're full down. I have a time shift to always just jump to this frame. So it's a bit of cleanup work, poly wire to give them some thickness. And material, pretty much that's it. And then I create a component this time, so it's actually writing out to disk as well. I've got this USD file for the wires, and I'm just grafting it in and placing them in a certain location in my hierarchy view. Phone mast, pretty similar thing. Actually, don't know where I created this guy. I think in subs and in object context, actually. Yeah, so in here, I did a very basic model of a phone mast. You can see it's super basic, but essentially did the same thing with vellum. Just let them hang down like that. Did some random strength, so they're all a little bit hanging longer or shorter like that. And then it's all like the same story. Write them to disk and graft them back in. And now we've got the wires. I'm transforming them twice, so I get two different ones. Small geo stuff is a little bit more interesting because it creates all these little props, but it's the same way as before. I'm pulling in my Megascan assets, same setup as before. Just did that several times and merged them into a single output node, which then allows the instancer to randomly pick one piece from the subnet. Hero rock is my foreground rock, which is here. Nothing crazy. I just copied and placed it. I created a volume box just to give me some depth. It's hardly visible in the render in the end, but this is essentially it. Then I'm assigning VDBs to the smoke plumes, volume shaders to the smoke plumes and the volume. And then it's about a single HDRI, which lights the whole scene. And you can now see the depth of the volume in here. I can disable that and it's a little bit more noticeable. Towards the end, it's just about creating Arnold render vars. So I'm creating spec direct, diffuse direct, all the fun stuff you usually do. I had to do a little bit manual stuff because I think there are some bugs with the current Arnold render settings node not respecting custom render vars. So I just recreated the render product myself, set everything up as I would, and have my render settings untiled, and then my sampling. Pretty simple. Actually, I forgot to enable adaptive on my final render, but that's not a big issue. Enable adaptive, and then I'm just storing the final scene as an entry USD file. So this scene, this USD file could be rendered in any other application that supports USD and Arnold essentially. And now we can quickly jump into Nuke so I can show you my work that I did in here. Very simple setup. I just have my render coming in. That's how the raw render looks. Not too much to do, honestly. Did a couple of hue shifts, just remove the warmth slightly. Color correction, more contrast. What did I do here? Just shuffle the Z into depth. Then I create the depth of field. It's maybe a bit much, but I just wanted to direct the focus to the mid-ground here, to that front building. And then light wrap the light wrap will make more sense in a sec. This is my background image. Did some color corrections to it, hue corrected it, scaled it, and then merged them on top. And the Light Wrap Pro is essentially wrapping the background light, the illumination onto my foreground geometry. Might be, again, a bit too much, maybe a bit too hazy, but I kind of like the look in the end, so I just went with that. Here I created a depth pass from camera distance just to help me fog up the background a little bit, so it's a little bit more tied in. Lens distortion, I like to do that because it just bends the image a little bit on the edges. This is what a lens would do as well. This is not what a lens is doing. It's pretty much what you see with your eyes probably, but a lens is always a little bit distorted on the edges. I created some glow, plus it on top. It's a little bit the same as a light wrap essentially. Then I created highlights from glow from the highlights. This always adds a nice touch, I feel, to metal pieces, metal surfaces. Get this nice glow here. A top gray to get a little bit more warmth back. And then I lifted the black slightly just to get this more like a old film camera look, essentially lifting the blacks a little. Chromatic aberration helps a little. It's probably, if I zoom in like that, it's just too strong. But what it does, it kind of enable or shows like a lens fringing, which happens on the lens on the edges of a lens, because the wavelengths are getting torn apart essentially. And a vignette towards the end, and some regraining, and that's it. So we can go back from front to back. Let's go here. Go maybe full screen. Yeah, and that is how I did this quick thing. And this took me roughly, let's say, 2 days. And again, if you want to get the Nuke scene files, the Houdini scene files, they are in my Patreon source files tier. So if you want to support me there, you get access to this and all my other previously uploaded scene files. Yeah, that is it. Thank you so much for watching, and I will see you in the next one.